Assalamualaikum warahmatullahi wabarakatuh. For our group, we are assigned to do a question number 2, which we need to design a Class B power amplifier for radio receiver system. My name is Umi Afika binti Azmi, and I will explain about the project background. So before we started, I will introduce my group members. As I have introduced myself earlier, my name is Umi Afika binti Azmi, and I will explain about project background. And next, for methodology and results, Julia binti Mohammed Jamil will explain about it. For discussion, Muhammad Afiq dan Muhammad Atta. And lastly, for conclusion and recommendation, Mirza Arif bin Nur Amali will explain about it. Class B amplifier is a type of power Class B amplifier where the active device conducts only for one half cycle of the input signal. That means the conduction angle is 180 degrees. Since the active device is switched off for half the input cycle, the active device dissipates less power and hence the efficiency is improved. So for our group assignment, the Class B power amplifier that we designed will be developed for radio frequency drive to transmit signal through antenna. In figure 1, there is a Class B power amplifier basic load line. Figure 2 is a Class B power amplifier quiescent condition. Class B power amplifier is also known as push-pull amplifier. Push-pull amplifier used to complementary or matching transistor, which one is being NPN type and the other one is being PNP type, with both power transistors receiving the same input signal together that is equal in magnitude but in opposite phase to each other. This results in one transistor only amplifying one half or 180 degrees of the input waveform cycle, while the other transistor amplify the other half of the input waveform cycle, with the resulting two halves being put back together again at the output terminal. So here is the derivation formula, which for input power, output power, efficiency and maximum efficiency.
Assalamualaikum warahmatullahi wabarakatuh. My name is Julia binti Muhammad Jamri and I will continue with methodology and results. This is our circuit design for power amplifier class B. The parameter that we use is B sign 10 volt, frequency 10 Hz, capacitor 100 microfarad, resistor and load 10 ohm, battery 10 volt, BC414 BP NPN and BC415 AP PNP. Next, this is the input and output waveforms that we get from the circuit. The first waveform is the input waveforms and the second waveform is the output waveforms from the circuit. That we can see that there is the crossover distortion from the waveforms. This is our output current waveforms that we get from the circuit. We get the output current around 800 milli to 900 milliampere maximum. That's all from me. Thank you.
Assalamualaikum and a very good day to everyone. My name is Afi Hatta and I will cover the analysis and discussion part. For the AC-DC circuit analysis, as you can see here, this is the Class B power amplifier circuit that we designed for the radio receiver system. In an ideal condition, we calculate the maximum output current is 1 ampere, but when we run the simulation, we only get the maximum output current around 996.17 milliamp. As observed in the sinusoidal waveform here, there is a time interval between the positive and negative alternation of the input when neither transistor is conducting, which produces crossover distortion in the output signal. Next, for the input and output power analysis, there are slight differences in the values that we get in between calculation and simulation. For the DC current, the difference between calculation and simulation is only about 0.0028 ampere, For the maximum output power, the difference is only 0.03%, and for the maximum output power, the difference is only 0.04%. These differences in values are due to the energy losses that happen at the resistor and the transistor that we cannot ignore when we run the simulation with the real hardware. Lastly, for the power efficiency analysis, the difference between the calculation as in ideal condition and the simulation is just about 0.26%. We can say that under maximum condition, a pair of transistors, each handling about 1.01 watt at most, can deliver 5 watt to a 10 ohm speaker, which is the load, while drawing 6.37 watt from the supply. Lastly, I would like to invite Mr. Mirza Arif to conclude our presentation and explain what are the recommendations that we can do in order to improve our Class B power amplifier for the radio receiver system. Thank you.
Hi and Assalamualaikum. My name is Mirza Arif bin Amali. I want to talk about conclusion and recommendation. Conclusion. The conclusion of this task, we are able to use multi-sim software and practice application in order to do simulation to compute the output signal. We are also able to generate an output waveform to solve the problem of the simulation. As we know, when Class B amplifier amplify the signal with two active devices, each operate one half of the cycle. Efficiency is much improved over Class A amplifier. Furthermore, Class B amplifier are also favored in battery operated devices such as transistor radio. In addition, Class B amplifier, also known as a push-pull amplifier configuration. Push-pull amplifier use two complementary or matching transistors, one being an NPN type and the other one being a PNP type, with both power transistors receiving the same input signal together that is equal in magnitude, but in the opposite phase to each other. Finally, we present a method to calculate the Class B efficiency. We conclude that the theoretical maximum efficiency is 78.49%, which is much higher than Class A configuration. This increase in efficiency is due to the low 180-degree conducting angle that allow the transistor to only absorb power from the supply when on AC. Recommendation. After that, we focus on the possible solution to the implement in order to solve the crossover distortion. One of them is to bias the base branch according to the desired level of linearity we want to achieve. As a recommendation, this can be improved by using a Class AB power amplifier to overcome the crossover distortion. The second solution is to add an operational amplifier to create a negative feedback loop in the circuit. The operational amplifier forces the output signal to follow the shape of the input signal, therefore limiting or eliminating the undesired crossover distortion. Thank you.
I'm an icon, man. And my girl about a 10. I should fuck her in the Benz.